picture a serene landscape, rolling green hills, a quiet valley, maybe a sparkling lake under a clear blue sky. It's peaceful, almost timeless. But what if I told you that beneath your very feet, an invisible giant slumbers, capable of unleashing devastation unlike anything humanity has ever witnessed? Deep below the surface, hidden from our eyes, lie Earth's magma chambers, vast molten reservoirs of unimaginable power. These are the engines of volcanic eruptions, and some of them, the rare and terrifying super-eruptions, could reshape our planet in ways we can barely comprehend. Let's dive into the veiled world of these hidden giants, uncover their secrets, and explore what they might mean for our future. Magma chambers are like the beating hearts of volcanoes. They're massive underground pools of molten rock, gas, and crystals, simmering and shifting far beneath the Earth's crust. Most of the time, they're quiet, biding their time. But when the pressure builds and the conditions are just right, they can erupt with catastrophic force. Regular volcanic eruptions, like those we see from Vesuvius or Mount St. Helens, are destructive enough. But super-eruptions, they're in a league of their own. Events so rare and colossal they can alter climates, devastate ecosystems, and rewrite human history. And the scariest part? We might not even know one is coming. To understand the threat of super-eruptions, we first need to grasp what sets them apart. A typical volcanic eruption might spew out a few cubic kilometers of ash and lava, devastating, sure, but localized. A super-eruption, by contrast, ejects at least 1,000 cubic kilometers of material, enough to blanket entire continents in ash and disrupt global climate for years. Think of it like comparing a firecracker to a nuclear bomb. The Yellowstone caldera, Toba in Indonesia, and Taupo in New Zealand are some of the planet's most infamous supervolcanoes, each powered by massive magma chambers that have erupted in the past with world-changing consequences. These eruptions don't just destroy landscapes, they can plunge the planet into a volcanic winter. Ash and sulfur gases blasted into the stratosphere block sunlight, cooling the Earth dramatically. The Toba super-eruption, which happened about 74,000 years ago, may have caused a global temperature drop of up to 10 degrees Celsius, potentially pushing early humans to the brink of extinction. Crops fail, ecosystems collapse, and societies struggle to survive in the aftermath. And while super-eruptions are rare, occurring roughly once every 100,000 years, their potential to disrupt our modern interconnected world is staggering. So where are these magma chambers hiding? They're scattered across the globe, often beneath places that look deceptively calm. Yellowstone National Park, with its geysers and hot springs, sits atop one of the world's largest known magma chambers. In Italy, the Campi Flegrei caldera near Naples is another hot spot, its restless underground system causing the ground to rise and fall as magma shifts below. Long Valley in California, the Taupo Volcanic Zone in New Zealand, and the Altiplano Puna Complex in South America are other key players. These chambers can span tens of kilometers, filled with molten rock that's hotter than 1,000 degrees Celsius, just waiting for the right trigger. But here's the kicker. We don't always know where all the magma chambers are. Some are buried so deep or are so diffuse that they evade detection. Scientists use tools like seismic imaging, ground deformation monitoring, and gas emissions to map these chambers, but it's like trying to X-ray a planet. The technology is improving, but there's still so much we don't know. Could there be a massive magma chamber under a quiet corner of the world, undetected until it's too late? It's not just possible, it's likely. Let's get into the guts of these beasts. A magma chamber forms when molten rock, or magma, rises from the Earth's mantle and pools beneath the crust. This magma is a mix of liquid rock, dissolved gases, and solid crystals, all churning together under immense pressure. Over thousands or even millions of years, these chambers can grow, fed by new injections of magma from below. The chamber's size, depth, and composition determine whether it's likely to produce a small eruption or a catastrophic super-eruption. The trigger for an eruption is often a delicate balance. Maybe a fresh batch of magma surges in, increasing pressure. Or perhaps tectonic plates shift, cracking the crust above and giving the magma a path to the surface. Dissolved gases like carbon dioxide and sulfur play a huge role too. As magma rises, these gases expand, turning the chamber into a pressure cooker. If the crust can't hold it back, the result is an explosive release. For super-eruptions, the sheer volume of magma and gas creates a runaway effect, blasting material high into the atmosphere and leaving behind a massive crater called a caldera. Scientists are racing to uncover these hidden threats, and the tools they're using are straight out of a sci-fi movie. Seismic tomography, for example, uses earthquake waves to create 3D images of what's underground, revealing magma chambers like glowing ghosts beneath the surface. GPS and satellite data track tiny movements in the Earth's crust, sometimes just a few centimeters a year, that hint at magma shifting below. Geochemists analyze gases seeping from the ground, looking for clues about the magma's composition and activity. Take Yellowstone, for instance. Recent studies have mapped its magma chamber in stunning detail, showing two massive reservoirs stacked atop one another, stretching over 90,000 cubic kilometers. That's enough molten rock to fill the Grand Canyon several times over. But just because a chamber is big doesn't mean it's ready to blow. Scientists look for signs of unrest, like increased earthquakes, ground swelling, or spikes in gas emissions. Right now, Yellowstone is stable, but it's under constant watch. Other sites, like Campi Flegrei, are less predictable. This restless caldera has shown signs of activity in recent years, with ground uplift and small tremors raising eyebrows. In 2017, researchers discovered that its magma chamber might be closer to a critical pressure point than previously thought. It's not a guaranteed eruption, but it's a reminder that these systems are dynamic, always evolving. If a super-eruption happened today, the consequences would be apocalyptic. Imagine a thick layer of ash covering entire countries, grounding flights, clogging water supplies, and collapsing buildings. Crops would fail as sunlight dimmed, leading to global food shortages. Supply chains, already fragile, would grind to a halt. The economic cost could run into the trillions, and recovery might take decades. And that's assuming the eruption doesn't trigger secondary disasters like tsunamis or widespread wildfires. Our modern world, with its dense populations and reliance on technology, is uniquely vulnerable. A super-eruption in Yellowstone, for example, could blanket much of North America in ash, disrupting agriculture across the U.S. breadbasket. A similar event in Campi Flegrei could devastate Europe's economy and displace millions. Even a smaller eruption in a densely populated area could be catastrophic. The 1815 eruption of Mount Tambora, which wasn't even a super-eruption, caused the year without a summer, leading to famines across the globe. Now imagine that on a much larger scale. Here's the million-dollar question. Can we predict when and where the next super-eruption will strike? The short answer is not really, at least not with precision, We're getting better at monitoring magma chambers, but predicting eruptions is like trying to forecast a thunderstorm years in advance. We can spot the warning signs, ground deformation, seismic swarms, gas spikes, but these can persist for decades or even centuries without an eruption. The Earth keeps its secrets well. That said, scientists are making strides. Machine learning is helping analyze massive datasets from volcanic regions, picking up patterns humans might miss. New sensors can detect subtle changes in gravity or magnetic fields, offering clues about magma movement. International collaborations, like the Volcano Response Plan for Yellowstone, are improving our ability to respond if disaster looms. But prediction is still an imperfect science, and super-eruptions are so rare that we have little historical data to work with. So, what do we do with this knowledge? For one, we keep studying. The more we learn about magma chambers, the better we can assess their risks. Governments and scientists are also working on contingency plans, evacuation routes, ash cleanup strategies, and food security measures. Public awareness is key too. Most people don't realize how much volcanoes shape our world, from the fertile soils they create to the existential threats they pose. But let's not live in fear. Super-eruptions are rare, and the odds of one happening in our lifetime are slim. The Earth is a dynamic living planet, and volcanoes are just one part of its story. By understanding these hidden magma chambers, we are not just preparing for disaster, we are unlocking the secrets of our planet's past and future. These molten giants have shaped Earth for billions of years, and they'll continue to do so long after we're gone. The next time you walk across a quiet field or gaze at a distant mountain, take a moment to think about what lies beneath. Those hidden magma chambers are a reminder of Earth's raw power, its ability to create and destroy in equal measure. They're a call to stay curious, to keep exploring, and to respect the forces that have shaped our world. The next super-eruption might be thousands of years away, or it could be brewing right now, silent and unseen. Either way, the more we know, the better we can prepare for whatever the Earth has in store.